And now that you know how to insert data into your database, let's go ahead and talk about how we can fetch data out of it. And we're going to be using this technique in the To-Do API. People are going to want to populate a list of all the to-do items they need to do, and they might want to fetch the details about an individual to-do item. All of this is going to require that we can query the MongoDB database. Now to kick things off, we're going to create a new file based off of MongoDB Connect. In this new file, instead of inserting records like we do here, we'll fetch records from the database. I'm going to create a duplicate, calling this new file MongoDB-find, because find is the method we're going to use to query that database. Down below, we can go ahead and remove all of the commented out code that currently inserts records. Let's get started by trying to fetch all of the to-dos out of our to-dos collection. Now, if I head over to RoboMongo and open up the to-dos collection, we have just one record. In order to make this querying a little more interesting, we're going to go ahead and add a second one. Right here, I can click to insert a new document. RoboMongo can delete, insert, update, and read all of your documents, and this makes it a fantastic tool for debugging. Right here, we can add a new document on the fly with a text property equal to walk the dog. And we can also tack on a completed value. I'm going to set completed equal to false. Now by default, we're not going to provide an underscore ID prop. This is going to let MongoDB automatically generate that object ID. And right here, we have our two to-dos. With this in place, let's go ahead and write our first query over inside of Atom. In Atom, what we're going to do is access the collection, just like we did over inside of the connect file, using db.collection. db.collection, passing in the collection name as the string. This collection is going to be the to-dos uppercase T collection. Now, we're going to go ahead and use a method available on collections called find. .find. By default, we can call find with no arguments. This means we're not providing a query. So we're not saying we want to fetch all to-dos that are completed or not completed. We're just saying we want to fetch all to-dos, everything, regardless of its values. We want every document from the to-dos collection. Now, calling find is only the first step. Find returns a MongoDB cursor. This cursor is not the actual documents themselves. There could be a couple thousand, and that would be really inefficient. It's actually a pointer to those documents. And the cursor has a ton of methods. We can use those methods to get our documents. One of the most common cursor methods we're going to be using is .to uppercase A array. ToArray does exactly what you might think it does. Instead of having a cursor, we have an array of the documents. This means we have an array of objects. They have ID properties, text properties, and completed properties. This ToArray method gets us exactly what we want back. We want back the documents. Now, ToArray returns a promise. That means we can tack on a then call. We can add our callback, and when things go right, we can do something like print those documents to the screen. We're going to get the documents as the first and only argument here, and we can also add an error handler down below. We'll get past an error argument, and we can simply print something to the screen like console.log, unable to fetch to-dos, and as the second argument, we'll pass in the error object. Now up above, for the success case, what we're going to do is print the documents to the screen. I'm going to go ahead and use console.log to print a little message. To-dos, and then I'll call console.log again. This time we'll be using our JSON.stringify technique. I'll be passing in the documents, undefined for our filter function, and 2 for our spacing. With this in place, we now have a script that is capable of fetching the documents, converting them into an array, and printing them to the screen. Now, for the time being, I'm going to comment out the db.close method. Currently, that would interfere with the code we have above. So let's go ahead and comment that out, save the file, and run it from the terminal. Inside of the terminal, I'm going to go ahead and run our script. Obviously, since we connected to the database with RoboMongo, it is running somewhere. It's running in this other tab. Over here, I can run the script. We're going to run it through Node. It is in the playground folder, and the file itself is called MongoDB-find.js. When I execute this file, we're going to get our results, and what do we have? We have our to-dos array. with our two documents. We have our IDs, our text properties, and our completed Boolean values. And this is fantastic. We now have a way to query our data right inside of Node.js. Now, this is a very basic query. We fetch everything in the to-dos array regardless of whether or not it has certain values. In order to query based on certain values, let's go ahead and switch up our to-dos. Currently, both of them have a completed value equal to false. Let's go ahead and change the walk the dog's completed value to true so we can try to query just items that aren't completed. Over in RoboMongo, we can go ahead and do just that. I'm going to right-click the document and click Edit Document, and right here we can go ahead and edit the values. I'm going to change the completed value from false to true. And then I can save the record, and over inside of the terminal, I can rerun the script to prove that it changed. I'm going to shut down the script by running Control-C. Then I can rerun it, and right here we have our two to-dos, one with a completed value of false and one with a completed value of true. Now, by default, a to-do app is probably only going to show you the to-dos you haven't completed. The ones you have completed, like walk the dog, will probably be hidden, although they could be accessible if you clicked a button like show all to-dos. Let's go ahead and write a query that just fetches the to-dos that have a completed status set to false. To get this done, over inside of Atom, we're going to make a change to how we call find. Instead of passing in 0 arguments, we're going to pass in 1. This is what's known as our query. Inside of here, we can start specifying how we want to query the to-dos collection. For example, maybe we want to query only to-dos that have a completed value equal to false. All we have to do to query by value is set up the key value pairs right here. If I rerun our script over in the terminal after shutting it down, what do we get? We get just our one to-do item. We have our item with the text equal to something to do. It has a completed status of false, so it shows up. Our other to-do with a text of walk the dog, that is not showing up down below because that one has been completed. It doesn't match the query, so MongoDB does not return it. This is going to come in handy as we start querying our documents based off of completed values, text properties, or IDs. Let's take a quick moment to look at how we can query one of our to-dos by ID. The first thing we need to do is remove everything from our query object. We no longer want to query by the completed value. Instead, we're going to query by that underscore ID property. Now, in order to illustrate this, I'm going to grab the ID from the terminal of the to-do with the completed value of false. I'm going to copy it using Command-C. If you're on Windows or Linux, you might need to right-click after highlighting the ID and click Copy Text. And now that I have the text inside of the clipboard though, I can head over to the query itself. Now, if we tried to add the ID like this, it is not going to work as expected because what we have inside of the ID property is not a string. It's an object ID, which means that we need to use this object ID constructor function that we imported previously in order to create an object ID for the query. To illustrate how that's going to happen, I'm going to go ahead and indent our object. This is going to make it a little easier to read and edit. Now that we have this in place, I'm going to remove the string and call new object ID, just like we imported it up above. Now, new object ID, as we saw in the previous video, it does take an argument, the ID. In this case, we have it stored as a string. This is going to work as expected. What we're doing here is we're querying the to-dos collection, looking for any records that have an underscore ID property equal to the ID we have right here. And now I can go ahead and save this file, give things a refresh by running the script again, and we get the same exact to-do. I can go ahead and change it for the walk the dog to-do by copying the string value, pasting that inside of the object ID constructor function, and rerunning the script. When I do this, I get the walk the dog to-do return because that was the object ID I queried. Now, querying in this fashion is one of the ways we'll be using find, but there are other methods other than toArray that are available on our cursors. We can explore other ones by heading over to the docs for the native driver. Over inside of Chrome, I have the MongoDB docs pulled up. These are the docs I showed you how to access earlier in the section. And on the left-hand side, we have the cursor section. If you click that, we can view a list of all the methods available to us on that cursor. This is what comes back from find. Down below at the very bottom of the list, we have our toArray method. One that we're going to look at right now is called count. Up above, you can go ahead and click count. It's going to bring you to the documentation, and the documentation for the native driver is actually really good. There is a complete list of all the arguments that you can provide. Some of them are optional, some of them are required, and there is usually a real-world example. Down below, we can figure out exactly how to use count. Now we're going to go ahead and implement count over inside of Atom. What I'm going to do is take the current query, copy it to the clipboard, and then comment it out. And down below, I'm going to go ahead and replace our call to toArray with a call to count. Let's go ahead and remove the query that we pass in to find. What we're going to do here is count up all of the to-dos in the to-dos collection. Instead of having a call to toArray, we're going to have a call to count instead. Now, as you saw inside of the examples for count, they call count like this. Calling count, passing in a callback function that gets called with an error or the actual count. You can also have a promise as the way to access that data, which is exactly what we did with toArray. In our case, instead of passing a callback function like this, we're going to use the promise instead. We already have the promise set up. All we need to do to fix this is change docs to count. And then we're going to remove the console log call where we print the docs to the screen. And right after we print to-dos, we're going to print to-dos count with a colon, passing in the value. Now this is not a template string, but I am going to go ahead and swap it out with one, replacing the quotes with the ticks. Right here, I can pass in the count. Awesome. And now that we have this in place, we have a way to count up all of the to-dos in the to-dos collection. Over inside of the terminal, I'm going to go ahead and shut down our previous script, rerun it, and what do we get? We get to-dos count 2, which is exactly correct. The cursor that we have here, a call to find, returns everything in the to-dos collection. If you count all of that up, you're going to get those 2 to-do items. Now, once again, count and toArray, they are just a subset of all of the awesome methods you have available to you. There are entire courses on MongoDB and MongoDB for Node. We're not going to be using most of these methods, but by now you should have a good idea about how you can implement them. Go ahead and scan the list for something that you think might be useful, check out the examples, and try to implement it in your code. Now, we will be using other methods, whether we use the MongoDB native driver or, as you'll see later, the library Mongoose. But for now, let's go ahead and do a challenge given what you know. To get started, let's head into RoboMongo, open up the users collection, and take a look at all of the documents we have inside of there. We currently have 5. If you don't have the exact same number or yours are a little different, that is fine. I'm going to highlight them, right-click them, and click Expand Recursively. This is going to show me all of the key value pairs for each document. Currently, aside from the ID, they're all identical. Name's Andrew, age is 25, and location is Philadelphia. I'm going to tweak the name property for 2. I'm going to right-click the first document and change the name to something like Jen. Then I'll go ahead and do the same thing for the second document. I'm going to edit that document and change the name from Andrew to Mike. Now I have 1 document with the name of Jen, 1 with Mike, and 3 with Andrew. The challenge for you in this video is going to be to query your users, looking for all of the users with the name equal to the name you provided in the script. In this case, I'm going to try to query for all documents in the users collection where name is Andrew. Then I'm going to print them to the screen, and I would expect to get 3 back. The 2 up above with a name of Jen and with a name of Mike should not show up. Now, in order to do this, all you need to do is go over to Atom, comment out our previous query, and add a new one down below. Take a moment to write this query, run it from the terminal, and make sure the correct number of documents returns. Remember, if you didn't have 5, you might not get 3. Just make sure that the data you view in RoboMongo is the data that comes back. Take a moment to knock this out, test it, pause the video, and when you're done, click play. How'd you do? Hopefully you were able to write that query and get the data back. If you were, that is fantastic. If you weren't, that's also great. We're going to go ahead and do it together right now. The first thing we need to do is fetch from that collection. This is going to be the users collection as opposed to the to-dos collection we've used in this video. db.collection, and we're looking for the users collection with an uppercase U. And now we're going to go ahead and call find, passing in our query. Remember, querying was a part of this challenge. We want to query fetching all documents where the name, lowercase n, is equal to the string Andrew, uppercase A. Now this is going to return the cursor. In order to actually get the documents, we have to call toArray just like this. We now have a promise. We can attach a then call onto toArray to do something with the docs. The documents are going to come back as the first argument in our success handler, and right inside of the function itself, we can print the docs to the screen. I'm going to go ahead and use console.log, json.stringify, passing in our 3 classic arguments, the object itself, undefined, and 2 for formatting. With this in place, we are now done the challenge. We have a query and it should work. We can test it by running it from the terminal. Over inside of the terminal, I'm going to go ahead and shut down the previous connection and rerun the script. When I do this, what do I get? I get my 3 documents back. All of them have a name equal to Andrew, and that is correct because of the query we set up. Notice the documents with a name equal to Mike or Jen are nowhere to be found. With this in place, we now know how to insert and query data from the database. Up next, we're going to take a look at how we can remove and update documents. It's all coming up soon, so stay tuned. I will see you next time.